Okay, it is time by the clock, so we're going to begin. Welcome, please find your seats. This is the plants BOF, and next slide. Want to remind everyone about the note well. This is the new note well with the cool QR code so that you can bring up the documents if you need to take a look. This covers your responsibilities to be a participant in the IETF. Please do not contribute unless you know what those responsibilities are, and you must treat each other with respect. It's okay to disagree. It is not okay to attack.
Sure. All right. So this is the agenda we have planned out for today. We're currently giving the introduction. As a reminder, so this is a BOF meeting. We have a proposed charter that's been worked on, that's been discussed on list. This is something that was previously brought to dispatch and has been discussed. And as we'll cover right after this, the main goal that we're trying to lead up to here are the BOF questions to ask this group, to ask the community if we think we have the right charter, if we're ready to work on this type of work in the IETF, and if we want to form a working group. But before that, we have to give the background and explanation of the problem space and what has been discussed so far. So we're going to be starting with a couple talks on the problem space and the background, the motivations for why this work is happening. We're looking at how CT works or doesn't work today, and how the trend of needing to add post-quantum security in is going to be impacting this area. After that, David Benjamin's going to take us through some of the solution space proposals that have been made, and specifically the work that had previously been taken to dispatch that led to where we are today, having this BOF. Then Devin O'Brien's going to take us through the charter that has been discussed on the list, and we can go through in detail and get the community's feedback on that. And then we're going to end with the BOF questions. And so just as a preview of that, and we will come back to that later. Oh boy. Come on, clicker. Doop, doop. There we go. So these are the questions that we're going to be asking at the end of the session here. We want to know if the problem statement is well understood, solvable. We want to know if the IETF is the right place to do the work. We want to evaluate the charter to see if the scope is correct. We want to see if the deliverables are correct. We want to see if you think that we should be forming a working group based on this charter, and if you're willing to participate. So please have these questions in mind as we're going through the meeting today, and help us answer those at the end. And if we can do that, we will have a functional and successful BOF. Yeah. No, I agree. Success is coming to an understanding of where we are, whether or not we form a working group. All right. Logistically, we are here in the room. We also have participants on MeetEcho. For any queuing remotely or in person, please use MeetEcho to do that. You can get to the on-site tool on your phone or your laptop. And we have a note taker. Thank you, PHB. And we have a backup note taker. Thank you, Joe. With that, are there any questions or agenda bashing? All right. Sounds good. Let's begin with then going over the problem space and background. Let's go into how CT works. And so we have Aaron and Matthew.
Howdy, folks. If you were in Acme, it's me again. I'm sorry.
think we need to request. All right. So if you would like to, you can request control of the slides, or I can. Okay, you're passing it now. Great. There you go. So I think you should be able to.
Perfect. Yep, I've got control. All right. Hi, folks. I'm Aaron Gable. This guy over here is Matthew McFerrin. Hopefully, I'm pointing in the correct direction on the big screen you've got up there. We are both at Let's Encrypt, or ISRG, the Internet Security Research Group. We issue a lot of certificates. We log a lot of certificates to current CT logs. We talk about this stuff a lot. We're here to talk about what does and does not work with certificate transparency today. Hopefully, most people in this room have a working understanding of how X509, especially Web PKI certificate issuance, works today. Hopefully, people have at least a vague understanding of how certificate transparency works today. Basically, every time a CA issues a certificate, they they submit it to a certificate transparency log. That log commits to incorporate that submission into a Merkle tree, and it provides some signatures over that commitment, and then, of course, later on, a signature over the Merkle tree head itself. Various monitors monitor the ecosystem of Merkle trees to make sure that CAs aren't doing bad and evil things. Now, why would you run a CT log? It turns out that running CT logs is not mandated by any PKI policy, including not even in the Web PKI. It is mandated that certificates come with SCTs, signed certificate timestamps saying that a log will incorporate them, but no one is required to run a log, so why would you run a log? One reason is just sort of transparency is good. We like having CT logs. We think that they're valuable to the ecosystem. More people should run them. So if you believe in that, maybe you want to run a log. As I was just mentioning, browsers require multiple signed certificate timestamps in certificates for them to trust that that certificate was actually issued in good faith. And so if you are, for example, a CA, you might want to run a log so that you can guarantee that there exist enough logs for you to satisfy this requirement with all certificates that you issue. Someone else's log might have downtime or miss some of its operational requirements or get booted from the log trust store because of misbehavior or something like that. So this is all well and good. There are some parts of running a CT log that are nice and easy. There are multiple high-quality log implementations floating out there. You can take one off the shelf and try to run it yourself. Those implementations are cloud ready. You can just spin up some AWS or Google Cloud or whatever and drop Trillion or Sunlight or whatever on that cloud platform, and you'll have something resembling a CT log running pretty quickly. And current CT logs have this behavior that when you accept a submission, you actually have quite a bit of time before you are required to sign a new Merkle tree head incorporating that entry that you've accepted. So you're basically allowed to run logs with a very, very high latency, and theoretically that should make things easier. The shortness of the content on this slide is a thing that we call foreshadowing. What makes running a CT log hard? One of the big things that you have to do as a CT log is actually merge all the things that you say you will merge. In general, in the Web PKI, most logs have a 24-hour MMD, max merge delay. That means that your log can never be down for more than 24 hours. Most services shouldn't be down for more than 24 hours, but it is a very big problem if a CT log is down for that period of time. In the last 10 years, 3 logs have had to be untrusted due to exactly this. Similarly, even if you don't have full downtime, you must incorporate every single submission that you promise to incorporate. If you issue an SCT, a signed certificate timestamp, and then fail to actually incorporate the corresponding entry, that is a violation of your contract. You have to make sure that you actually incorporate all of those things. We've lost 6 logs to this problem in the last 10 years. More reasons that they're hard. Logs today support really high read load. Certificate transparency monitors fetch every single thing that's been incorporated into your log since the beginning of time. And ideally, the system would support many monitors. We want lots of people to be monitoring CT logs. But that results in actually absurdly high read load. And if you try to impose rate limits to mitigate this high read load, you make it so that someone spinning up a new monitor can never actually catch up. They will forever be consuming new entries slower than you are adding new entries. Also, you have to support high write load. When you're running a transparency log, every CA in your PKI can arbitrarily choose to write to your log. Your load is not dependent on your own operations, it's dependent on everyone else. You're writing a lot of redundant data to the log. You're in the web PKI, you're submitting both pre-certificates for the creation of SCTs, and frequently the final certificates that contain those SCTs also get logged to the same certificate transparency logs, so the same cert shows up twice. And then third parties are copying entries from one log to another, consuming the entire history of a log run by one person, and submitting every single one of those entries to a log run by a different organization. So we are duplicating data, triplicating, quadruplicating many, many times over. I think one of the later presentations has better numbers on this, but very, very high write load. And finally, all of this leads to the sort of core reason that running a CT log today is really, really hard: data size and cost. For a current log in the web PKI, you're talking about something like 10 terabytes of disk to store 6 months worth of log data, and about 10 terabytes worth of bandwidth to serve all of the read and write requests every day. It is a lot. It is very expensive. You try to run one of these on a cloud provider and they get very upset at you, even though it's supposed to be very easy. And all of this
upset.
is...
The upset bit is your bill.
Yeah, that's what I said, right? And all of this, of course, is before we take into account the size increases that will be coming with post-quantum public keys and post-quantum signatures, which someone else will be talking about momentarily. So all of this is sort of to set up, like, the certificate transparency ecosystem is a bunch of really, really good ideas that we want to preserve, and a bunch of major operational hurdles that have resulted in the ecosystem not growing the way we want and not really serving the purposes that it should serve in an ideal way. So really quick, in conclusion from this bit, even ignoring the full contents of the charter discussion that we'll be having today and the full contents of the drafts that have been proposed to be worked on in this theoretical working group, if all we assume is there exists a world where signing a new Merkle tree head is the act of issuing all certificates under that Merkle tree head, we get a ton of benefits. Your leaves can be smaller because you don't have to store the entire certificate, just something that is provably bindable to that certificate. You don't have to store pre-certificates because there's no pre-submit, final submit. It's just this entry in the log is the certificate. There's no merge delays. You're running the log yourself. You don't have to like say, oh yeah, I'll merge it within 24 hours. You just put it in the log immediately. There's no third-party rights because it's a first-party log. The log is the certificate authority. You're only incorporating certificates issued by itself. There's no near duplicate leaves, pre-cert and final cert, leaves getting copied around between various logs. All of this massively reduces the data size, it massively reduces the bandwidth. All of these ideas make the concept of running something that looks like a certificate transparency log so much more palatable. There is still a queue of unmerged entries, but failure to process that queue is just failure to issue, not a log-killing death sentence. So yeah, that's sort of the state of transparency today and why I'm really excited about improving it via the work that this group thinks it wants to do.
All right. Thank you for sticking perfectly to time on 10 minutes. Do you want to take any clarifying questions if there are any things that we want to bring up here? Again, not discussion at this point, but any clarifying questions? All right. I don't see anyone in the queue, so I think at that point we can move on. Thank you very much, Aaron and Matthew. And we can jump over to our next deck. You have control. Great.
Well, that would help.
Oh, I have the power.
One moment.
Ah, I no longer have the power.
There it is.
You have the power once more. Use it
Amazing.
wisely.
Thank you. Okay. Hello, everyone. I'm Tom Wiggers. I work for PQ Shield, which is a company that does PQ stuff. But I think most relevantly to today's talk, I basically obtained my PhD creating tables about post-quantum in TLS. And I'm going to show you some tables today. So if we look at the TLS handshake, there's quite a bit of public key crypto going on there. We have in the client hello message, there's a public key for a key exchange being sent. Then in the server hello, you respond with a ciphertext now because we've all switched to chems. And then there's the whole mess of all of the certificates. You have the leaf certificate, which is a public key and a signature. Intermediate certificate, usually at least once, maybe more. Each a public key and a signature. And as was just shown for a certificate transparency, well, you're probably going to send 3 of these SCD staples along, and each of them is another signature. 3 because you maybe want insurance against one of the logs failing. And then you have the handshake signature. And I'm not even going to consider OCSP, which is another opportunity to include a signature, but fortunately, that's being killed off right now. So that's a lot of signatures. And if we sort of lay that on its side and then start labeling each of those signatures with what algorithm we're using and how much bytes that adds up, then you get a very busy table. What I want you to focus on mainly is the column on the right that says total size. And if these first 2 rows basically represent the current, just all classic crypto, the basically best case scenario with all elliptic curve stuff. And then the cost of all of this crypto is about 600 bytes. So it's not nothing, but not a lot either. And even just switching over only the very first field, this key exchange algorithm, you immediately jump up to 2.2 kilobytes. And that's just the crypto, not all of the ASN1 policy fields and all of the other stuff that surrounds certificates and things like that, or the overhead from TLS itself. And then we start getting into actually replacing all the authentication, so all of those signatures with post-quantum things. And then you see an enormous jump. If we use MLDSA for everything, then you jump up to well over 18 kilobytes. If you use MLDSA at level 5 because you are mandated to by some national security agency or something, then it is extremely ludicrous. And even if we would use Falcon or the FNDSA algorithm, which is a standard should be coming out for soon, it's quite a lot more aggressive in its the way that it needs to be implemented. It's very difficult, but you get some size benefits for that. But still, 7.4 kilobytes of data. And at level 5, it's still almost 15K. You don't have to remember all of these numbers again. It's mainly about this column on the right. Things do get big. We can play around with things a little bit. If you don't like Falcon on the end, you might need to put in MLDSA there. But yes, almost 10K still. And even if we're very, very, very forward-looking, I've heard of this algorithm called Mayo. It's coming up in the standards. NIST is working on it. Let's just wait for Mayo. We're still looking at 6K. Very long story short, things, at least per this slide, increased by at least 10x in size. I'm going to show you a bunch of benchmarks and things that show that this has an impact on the performance. And before I get into that, it's important to note that all of these algorithms are stupid fast in the implementation. So any effect in a benchmark is all due to sizes. So very quickly going through that. In my thesis, I was a young PhD student. I was doing these benchmarks of the performance of all of these handshakes. And I was like, okay, I know they're all fast. I see a little bit of effect on the size of the data, but why the hell is this upper right corner jumping up by another round trip? And that was when young Tom learned about the TCP initial congestion window. I'm a cryptographer, right? Actual practical things are foreign to me. But this somewhat artificial, some argue, other people threaten to throw me out of windows when I suggest, like, could we maybe increase this? This artificial window means that if you want to send more than 15 kilobytes of data in a message, in the first few messages, then you need to pay a penalty of having to wait quite a bit longer. So this is something that is a very immediate problem. And as we saw in my table, most things have problems with this setting, but maybe we can stay around it. Well, Bas Westerban at Cloudflare did a bunch of very helpful and often referenced presentations, and they see that it's a little bit more nuanced than this cliff. You slowly start seeing an increase in the slowdown. I've pointed at the first arrow shows what it would be if you add MLDSA for around 18 kilobytes of data. And you see that it slows down things by about 25%, which is significant, but maybe less than a full extra round trip. But it should also be noted that they cheat. Someone needs to call the RFC 6928 Internet Police and complain about them using a congestion window of 30 MSSs instead of just 10. So maybe this part on the right where you see that there's a big cliff going upwards should be a little bit more around this 15 to 20K mark. That's what the theory also supports. So do we have more info? Sorry, it's been a few weeks since I made slides. So, and it's 11 p.m. The practical stuff supports sort of some of the theoretical results, even though it's a little bit more nuanced. And now we need to place ourselves in sort of the feet of some person on the internet that wants to run a server. And we're asking them to add 15 kilobytes to the TLS handshake, potentially slowing down my website by 20%, maybe more. And it's for something that doesn't exist today. This guy is just going to yell at you and tell you to go away. And we do want this guy to deploy PQC. So basically, I think that this is the problem that I would like to see solved. Google seems to be also of this opinion. An unnamed Google Chrome PM has complained at length on their blog. They noted that for the current deployment, so just key exchange, they see that they're already seeing a 4% median latency increase, but also much worse on the tails. It would be great if they show more data. And they also sort of set this goalpost for that they think that adding anything more than 7 kilobytes, including key exchange, to the handshake is probably going to be very hard for them to swallow. But that's just the opinion of one browser company. And there's other people who've done other measurements, and maybe they argue it's not so bad. Panos and Will Childs-Klein have published this paper that measured the time until the end of the handshake, and they show that the time until the last byte arrives usually stays below 5% in terms of how much that gets delayed. Although under lossy conditions, that's bad, worse. And it's a little bit nuanced. They are measuring fairly large TLS handshakes. And Cloudflare's data show that actually the median data transferred in a resumed quick connection is only 4.4K. So adding 18K is quite a lot of payload relative, quite a lot of overhead respective to payloads. Even for non-resumptions, the median is only 7.8K of data. So yeah, things are very expensive. And it seems that we want to be able to convince that guy that runs a server and wants to add PQ but doesn't really want to pay this price. So I think the question is, should we be looking for better things? And yeah, I would answer this in the positive. Any questions?
But if you have any clarifying questions, you can queue up. Not any. Okay, great. Oh, we have one, Jean-Pierre.
Hi, Tom. Thank you for the presentation. I know you're familiar with LMS and HSS, and now everybody in the room is going to groan. Have you ever characterized like the impact on TLS for those algorithms?
Yes, I can refer to the thesis that was linked somewhere. There are some longer and better tables in there that also include some numbers on XMSS. The main problem with XMSS is the verification time tends to be quite expensive still. So you then start paying a little bit of a price in sort of the runtime overhead. But yeah, you could play around even more with the layout of things in the roles of the different things in Handshake. And for example, try to use XMSS in a root certificate. We did need to come up with some new parameters that were smaller than all of the level 5 stuff that was out there to get the most out of that. And yeah, there's more details in my thesis.
Okay, thanks.
All right, and we have Scott and David. Feel free to come up.
I just want to point out that if you're worried about speed, LMS is approximately 3 times faster than XMSS.
Okay, maybe we picked the wrong algorithm in the benchmarks that we did. It's very possible. Okay, I'm going to get away. Have a good stay in Montreal, everyone.
Appreciate it, Tom.
All right. Hi, everyone. I'm David Benjamin, and it's good to see everyone here at this BOF, which apparently means bunch of friends or something. I'm not sure. All right, so I'm here to talk about the solution space and the dispatch work that sort of led to this BOF. All right, well, so we saw that post-quantum is too big, and that is about as undirected of a statement as we possibly can get. So I'm here to try to help answer this question and convince you all that this problem is solvable, or at least we can make some significant improvements, and also to give you all a sense of what the scope of this work would be. So we're going to talk about the key ideas from the dispatched work, why those ideas help, how that fits into how systems look today, so you can get a sense of like what we would need to change, and also how this fits into sort of other work that is imposed in this space, so either for this or other related problems. All right, so let's get started. If you take nothing away from this talk, if you take nothing away from this talk, remember, don't log what you issue, but you should issue by logging. So what do I mean by that? In a traditional CA today, you first sign something and get a certificate. Then you take that signed thing and you log it, and you collect SCTs or signed certificate timestamps to prove that you did this. And we did it in this order because we had a PKI already, and then we layered CT on top of it. So we had to work in terms of the objects this PKI already built. And a lot of the complications that you saw in Aaron's talk stem from this gap between issuance and logging. By the time the CT log sees the certificate has already been issued, and we have very little options to say no. But in this other design Merkle tree sorts, the CA first logs, then it signs a checkpoint, which is the state of the tree, and then it collects co-signatures to prove that it did so correctly. So what do I mean by that? So the CAs run an issuance log, which is a per CA log that describes what they issued. We'll talk about what goes in there later. Certificate requests come in, the CA thinks very hard, does its domain validation, whatever else, that's not being changed. And if it is happy, then it adds a log entry, and each log entry describes the information the CA wants to certify, like Bob's key is 1, 2, 3, 4, 5, or whatever. Then the CA signs checkpoints, which is the top of the parts of the tree to attest to what the state of the tree is. And then we collect co-signatures from witnesses and mirrors to prove that the tree is operated correctly, there's no split views, and so on. And we'll talk a bit more about what that means. So you notice I haven't said the word certificate yet, at least I don't think I have. A certificate, so we don't actually put the certificates in the logs. Rather, the certificate is a structure that proves some entries in the log. So if you're familiar with an X509 cert, there's a TBS certificate, which basically describes what you're issuing. That is what is actually in the log entry. And the thing that is the quote unquote signature is an inclusion proof in the Merkle tree and the various co-signatures. And given this, a client can verify, first you run the inclusion proof to rebuild the top of the tree, and then you check the co-signatures, and then you can evaluate some policy analogous to what you have today, where you want some signature from the CA because the CA was trusted to validate stuff, and you want some number of signatures from other parties that are trusted to like ensure that the tree was globally consistent and whatnot to satisfy your transparency needs. So why do this? We've sort of rearranged stuff, but like, why does this help? And the reason this is useful is that we can get smaller log entries, we get fewer log entries, and we have room to make the certificates more optimized. So first, the smaller log entries. We do not pay post-quantum tax with the log entries like we do today. The signatures are removed from the entries themselves and moved to the top, so we don't have per signature and everything in there. We can also replace the public key with a hash of it, because if you're doing monitoring, you only actually care that my key was in there and not someone else's key, and you only need the hash for this information. This is all possible because we made logging the same thing as issuance, so you get non-repudiation from the one signature at the top, and the client can redo this hash public key transformation. And we have like a little simulator over today's logs. If you naively move to MLDSA 4.4, the smallest one today, the entries get about 8.3x larger after you gzip them. Even without converting the signatures at all, compared to CT today, this design gets the logs 12 times smaller, and then you multiply those together, and it's about 97x smaller. So we're at 2 orders of magnitude size decrease, which is a pretty substantial. I see there's a bunch of folks in the queue. Whichever.
We have 2 clarifying, I assume.
Hopefully.
Yeah, it's a clarifying question.
Sure.
First off, you asked what we all are. I think we're birds. So hello, bird. Can you go back one slide?
Sure.
No, one more. So the clarifying question is about the term X509 here. Am I expecting this to be like when you say signatures become the X509 signature, is this like actual literal physical X509, or are you doing something that's a bit X509-ish?
So I'm sure the working group will like have loads of fun debating this one. In the draft right now, sorry, in the draft right now, we have captured it in an X509 certificate. There's, you could encode it in whatever way you want, but it is like it seemed useful to figure out, like, is it possible to scribble into X509 and fit into those? And the answer is yeah.
Yeah, this is a similar question to that. Is this independently verifiable if all I care about is the signature from the CA and not from the rest of the logs, not from the witnesses?
Sorry, could you say that again?
Yes. Is this independently verifiable if all I care about is the signature from the CA and I don't care about the CT?
Yes, you can just ignore the signatures that you don't care about.
And that's safe?
Yeah.
I believe.
I mean, I hope so. It is, the people currently ignore CT signatures all the time, and they're fine.
Yes, that's true, but they're not part of the signature block. They're part of something else. I just want to make sure, okay, you believe that's safe. We'll assume yes.
The intent is that it is safe.
Okay.
I am sure the working group have loads of fun.
That sounds good enough for me.
All right, where were we? Okay, so we get nice small sizes. So, whatever pain you have by running CT logs, divide by 100. We also get fewer log entries. So Aaron mentioned that you have both pre-certificates and final certificates. This is kind of a consequence of how SCTs were embedded into the certs, which was needed for like a mess of backwards compatibility problems. This is now gone. We only have one entry. Additionally, because entries are cross-logged between certificates, between logs by third parties right now, even though the browsers may say, oh, we only need like 2 logs per certificate or so. You put it in one of them, and then some third party is going to go in and sync it into all of the others anyway. So if you have n logs, every certificate is actually represented up to 2n times in the ecosystem. So the more logs you add, you would think you add more redundancy into the system, but actually the monitors have to do more work. In this system, if you flip it around and make it so that the trees are per CA, then each issuance produces only one entry in one tree. The mirrors we may have some mirrors, but they're all provably identical, which means that the monitors only download each entry once. If you know you've seen entry 42 of like this log over here, you don't need to go download it again. You can just sort of check the inclusion proof to make sure they all match up. And we also don't need this external logging endpoint, this external write endpoint, because the entries themselves come from the folks who run the logs in the first place, which means that per log, we get a 2x entry count reduction per certificate per log, on top of the 100x we were previously talking about. And I counted about 10 logs that are currently active for the second half of 2025, which means that across the whole ecosystem, we're getting up to 20x decrease, assuming that the third-party log syncers are like doing everything. And then finally, so this is all about the log themselves. So we haven't talked about the TLS handshake. We can do this nice optimization in the TLS handshake by observing that you can actually, so suppose you add add an entry like today. You can use the current tree state to build a certificate, but you can also use the next one and the next one and the next one. So any future checkpoint will work. So we can designate some periodic checkpoints as landmarks, as common points of reference between the server folks and the clients. And then the clients can get these hashes of these trees out of band, so we check the signatures ahead of time. And since these signatures cover large chunks of the tree, this amortizes that cost. And now the servers only need to prove inclusion to those pre-distributed landmarks. They don't actually need the signatures, which means we can ship just one inclusion proof, which scales with the volume of the logs, but we estimated it at about 700 odd bytes, which is 1/10 the size of just 3 MLDSA signatures. Now some caveats here. If you're getting a certificate, the landmark may not be allocated for a while, so you have to be willing to wait a bit, and some clients may be out of date. And so we can have 2 certificates from one log entry, configure them both on the client, on the server, and then use TLS negotiation to pick the right one and sort of optimize it when we can. And otherwise, this connection will still work. We just sort of have to pay the extra size.
Yeah, I think you answered my question, but let me just try to let me try to up level it a tiny bit, right? In the current CT ecosystem, I can issue right away without waiting for anybody else. Sorry, I have to get the SCTs, but I don't have to wait for them to include it in some log of their own. This is the equivalent of that. The signature list is the equivalent of the SCTs, and the other one is the equivalent of the full inclusion proof with STH discipline.
Flip it around. So the full certificate is the equivalent of today, so as soon as with roughly the same sorts of delays as before, you can immediately get it into the log and produce some certificate. But in order to produce a certificate that's smaller, then you have to wait a little bit. And so you get one certificate immediately, and then you wake up your Acme client a little bit later and get the other one, and then.
The same thing is true that the full one is not necessarily publicly verifiable in the same way as the other one is, right? So,
So they-
so right now the you can't verify the inclusion proof. It's just like you can't with the current.
So there's an inclusion proof and signatures over the top. So you do need to rely on the signature check to like believe this root hash, but it is of the same entry that will be there.
Right.
So-
But what I'm trying to get at is that like is that in the in the part of SCT, in the part of CT that nobody really does, right? They wish they do. You have actually public verifiability of all the inclusion that is reified in, like you can verify the inclusion proof with the self-contained thing, and you have like the gossip tree heads or whatever, and you can verify public verifiability without doing a bunch of communication. And that's true. Is that the situation here too?
I'm not sure I fully understand the question, but I think it sounds like you're talking about the like sort of auditing question of SCTs. So this is in some sense orthogonal in that in the full certificate case, you still have this like analogous problem. We're not currently trying to do anything about that. However, I expect that will be a lot easier in this picture, partly because hopefully a lot of the volume will be shifted to the signatureless ones, which are a lot easier to do this verifying. And of the volume that still needs the like auditing type thing, you only need to audit at the granularity of the trees that are being signed. And so that means the sort of like amount of information you leak by asking about that one is smaller. And so maybe PIR schemes become a little bit more viable, but I'm just sort of talking off the cuff right now.
Thanks. I think I understand the situation.
All right. So that is a whole bunch of stuff. How much work does this entail? And hopefully, and I guess we are really just rearranging our existing garden. We're not like building some like fundamentally new things. So if you take the view from the CT ecosystem, the players are roughly the same. The traditional CAs become Merkle tree sort CAs. The CT logs become the various cosigners, the mirrors and witnesses, and they have very similar responsibilities, security assumptions, and who talks to who are all about the same. Really, all we've done is taken the Merkle tree construction step responsibility and moved it from the like quorum of logs who have to each do their own trees and move it to the CA who like builds one tree for everyone who cosigns them. Just to save on time, I'm not going to go walk through this picture, but if you look at the roles today and the roles tomorrow, this is approximately the same picture, but we just renamed one of the lines and put an extra triangle. So, hopefully, like we don't need to like build new edges in this diagram or anything. Did that not work? There we go. From the perspective of the transparency ecosystem, we're actually building on a lot of existing work in CT. The tree is the exact same tree structure from 6962 and 9162. So all the operational experience we have in the CT community who has been learning to run these giant logs applies here. Now the CAs will be running them, but we can reuse the current generation of logs. If you've heard of this thing called tiled transparency logs, or it's also been called static CT API. It's this like new log protocol and sort of implementation strategy where the logs are just collections of immutable cacheable resources. So this fits very well in like sort of CDN hosting architectures or various other things. There are like 3 different implementations of this. So I'm hoping we can just sort of tweak it minimally and then just like apply it, and then the CA folks can run that. There are some changes in MTC, but they aim to address many of the remaining operational challenges that Aaron sort of talked about. And other work that the CT ecosystem is currently doing on its sort of tree structures, this thing called V-index that's really cool. It just sort of applies without any changes because they all sort of work on this common tree structure. Likewise, I keep talking about these witnesses and mirrors, and I haven't said what they are. This also comes from existing CT community work. Witness is this lightweight service that enforces append-only views. You sort of exchange consistency proofs, and you can use a quorum of them to defend against split views. And a mirror is just a witness that also mirrors a copy of the log, because in CT today, we don't expect the CAs to be hosting large volumes of data. And so we can sort of get something similar by asking for mirror co-signatures instead of witness co-signatures. In the encoding, the exact encoding, we'll have to figure that out. But sort of conceptually, what's going on is in an X509 certificate, there's 2 parts. There's the TPS certificate, which is some information about subject certified by some issuer, and the signature, which is just some byte string that lets the relying party go from the subject to, like, if you believe the issuer, then you should believe the information in the TPS certificate. And in this model, the combination of inclusion proofs and co-signatures is what lets you believe the TPS certificate. And so we can just sort of jam them into the signature field, or some equivalent field in some other format. And so one way you can kind of think about this is really just a funny signature algorithm that happens to log everything it ever signs. We talked a bit about how there's two different certificates. Part of the observation here is that some of our size costs come from the fact that we traditionally deploy TLS servers with only one certificate, and so they're limited to the lowest common denominator. But TLS is an online protocol. We negotiate every parameter we get. It's like a very convenient way to do transitions from like one world to the other. There's a whole bunch of text in RFC 8446 already about how to select certificates. The TLS working group has this draft that like extends this some more, and we can use that to switch between the two certificates. This is why in the draft charter we specifically talk about interactive protocols. Oh, and I am running very low on time, so I will. Oh no, I misread that. Great. Okay, so that is all these pieces. All right, and so for the final part, sort of the broader solution space and what we can build on top of this. There is all kinds of exciting work happening around transparent PKIs. I didn't talk about the subtree optimization for inclusion proofs. We can figure out the certificate construction. There's a lot of cool stuff you can do where you can put other structures in the logs to get better revocation. We can try to work on the sort of protocols on the transparency ecosystem side. Monitoring lookups could be a lot better. Insert your cool IDs here. And through all of this, we have to figure out how to charter a working group. And so in this draft charter, we've been trying to focus on putting down, like getting the foundations right. So the things that we need to get done in sort of the first step. And then everything else we can kind of build as extensions on top or sort of like indices on the side or whatever else. And so the hope is that like as like more work is identified, we can sort of branch out from these roots and build a bigger tree, or I don't know, puns. I see this. All right. I can see we have someone in the queue.
Yeah, see, you've got it in the scope of work, but revocation, have you given thoughts to that? Because the thing is that we've been pushing this idea of making the certificate lifetime shorter and shorter and shorter. However, with this particular approach, you've got because each day you're issuing a signature over the tree head, that is effectively like creating a new certificate for all the things that are underneath it. And so potentially it might be that we can save ourselves a bunch of work by including revocation as a first-class object as part of this thing. So instead of having to reissue the certificate over and over again, it's implied to be correct unless it is explicitly revoked. And then we might want to bring on board things like Bloom filters and all the strong revocation mechanism that has been proposed in PKIX over the years, but never really got started.
Yeah.
And that might save us some time.
So I mostly live in the browser world, and in that world, we cannot have the clients talk to anyone other than the servers themselves. And so every solution tends to be isomorphic to short-lived certs in some way from the server's perspective, in that the server needs to get a fresh something, whether that's the same certificate with like extra stuff attached or like a new certificate or whatever else. So it's true that like in the short-lived certificates model, we sort of have to keep adding new entries to the log. We are also getting like 100x more breathing room on that like calculus. Possibly there's more interesting stuff to do here as well. But also, you know, we also don't want to solve every problem all at once. So I think this will be stuff for the working group to figure out as, you know, we progress down here. But yes.
Okay, we have John, and as a reminder, clarifying questions here on the talk.
Oh, I was just going to kind of respond a little bit to what Philip was saying, because he mentioned revocation. So about, 6 months ago or something, I did a presentation at LAMPS about Merkle tree ladder. It's a Merkle tree structure based on revocation. So I guess for me, this Merkle tree, I think to go with what you're saying, the Merkle tree has a lot of power to make things more efficient. And that's what you're like, basically you're talking about here in terms of certificate discovery. So I guess I just wanted to say that.
I think I only had a couple more slides. Let's see. Yeah, so if you sort of imagine the like space of things that are going on, the sort of initial charter tries to sort of target at like the things surrounding the certificate construction, what's needed to like interoperably construct and deal with certificates, and then sort of the rest of the stuff we can like branch out to later, or like, you know, whatever makes sense. All right. Also, I have some funny pictures. Oh, I should probably mention that. So this work, there was a first version of Merkle tree certs, and this is like the second version. And we were coming up with a second version. We called it photosynthesis because we were making certificates out of sunlight, which is the name of CT. Anyway, puns.
Hi, David. Thank you for this great and clear presentation. It definitely shows that you did some homework, so I appreciate that. One of the slides you said there was the one about like who was doing what to whom, and you said that some of the work was being moved to the CAs. My assumption is that you've got CAs that are willing to do this work. Yeah, that other one, I think, the one with the
this one, or the
yeah, the one that was before it, I think.
This one.
That one, yeah, where you moved like down to the Merkle tree construction. I assume that there are some CAs that are like, yeah, that's like a
I don't
thing.
want to speak on their behalf for
Fair
them,
enough.
but,
Okay, but
there
I
are
assume that
representatives from CAs in this room, and I will let them, you know, speak however.
Okay.
Yeah.
Thanks.
I would point out that most of the large log operators today are also the largest CAs. So while this chart shows the people changing, it's actually in many cases the same people.
I think that's absolutely true, Matthew, but I think we also care about having, you know, many CAs participate in this. I think that's going to be fine, but
Just speak up.
oh, sorry, Dennis Jackson, Mozilla. I think that's true, Matthew, but I think we also care about having CAs smaller than the current CT log operators participate in this. I think that's going to be fine, but I want to keep that in mind.
I think that's actually going to be some really interesting points on the browser policy side. One of the challenges with operating a Merkle tree log is making it public and sharing it. So on the browser policy side, you know, there's been some discussion about whether a CA needs to expose it themselves or purely have it copied into mirrors, and determining how many signatures we need, like maybe 2 mirrors and no public CA log, or one log that's public from the CA itself and 1 mirror. Something like that is possible as a policy, but I think, you know, that kind of structure is more on the CAB forum side or the browser policy side than the actual construction of the certificate itself. I think also, you know, in terms of maintaining robust audit logs internally, this is something CAs are already required to do. You know, I think it's actually not a huge leap to go from whatever audit logs you need to have internally already to a cryptographically verifiable audit log of your issuance.
And I can imagine that different PKIs would want different things out of this. Like, not everything is the web PKI, and you know, there are folks who sort of run like more private PKIs, and they might have need for something transparent, like, but maybe the like ratio of like, you know, which parties can run which size of things is different there. And so I think it'll be useful if we build something that's like at the protocol level fairly like unopinionated, and then we can like do things at different layers. Anyway.
Hey, so it was talked about in the first presentation, I believe, about how CT works, that, you know, sometimes CT logs mess up and they like lose some data or they sign a fork or something. And when that happens, what you do is you throw away the CT log. But because you've moved that work now, if a CA messes up building their log, is your thought that you throw away the CT, or what are you thinking there?
That is a great question for the working group. I have some thoughts. I haven't like written them down anywhere. Other people probably have other thoughts as well. Like, yes, this is definitely something to figure out. But I think probably we're probably stretching the like bounds of above more and more. So.
Aaron, did you want to get in queue? Or?
No, I was going to give a slightly more fleshed out answer to that, but I think we're right that it's not necessarily the full subject of this BOF, just a thing to address on the list.
Sounds good. Thank you.
Okay. All right, so I think that's it for here. Thank you for keeping that to time. Thank you for the good discussion and clarifications here. And next up, we are going to switch over from looking at the technical aspects and the problem space and the solutions that are being proposed to get into the more administrative parts of how do we actually want to tackle this work? What is the proposed charter? And Devin's going to be taking us through the current text that's been discussed on list. All right.
Hello, my name is Devin.
Ooh, clicker, nice. Is it the arrow? Should be the right arrow.
Great. Okay, so just for anyone who wants to read along, the current plants charter is on GitHub under the Merkle Tree cert repo at this URL. But this is sort of the version of the charter that has gone through several rounds of edits and suggestions. So the point of this conversation is to talk about where we started, what feedback we got on the charter, and then where we've ended up, and what possible open questions there might be. I thought I was going first, so I put a pun warning, but that ship has completely sailed by now. So if you're still in this room, that's on you, sorry. So the point of this slide is not to read. The point of this slide is just to show this is the entirety of the charter that we're talking about. This was the V1 charter. On a single slide, this looks like a lot of words, but seeing as how to create this presentation, I had to reread every charter email message total. We are at a bike shed ratio of 3.9 words of charter language per email discussing the charter. So congrats. Yeah, so we started at this in early August. This was the just initial draft to start the point of conversation. And from here, there was a variety of feedback. And the way I've sort of collated this is by topic. So some of the initial feedback we got was regarding the purpose, the PQ signature cost as sort of this motivating problem we're trying to solve. The initial text was for mitigating this cost was deemed too vague. We also, there was another message that was saying we should actually have the charter focus more on design trade-offs, among which PQ signature size is a major compelling motivation. And then there were some concerns voiced that if we just focus too much on the signature costs, we might miss the opportunity or like unintentionally descope some very easy wins when it comes to a variety of other improvements we could possibly make here that aren't directly related to the PQC migration. Additionally, there was some comments on the properties of the system that we're trying to get out of here. Comparable was very contentious as a word to choose. And so it's comparable to what? What does that mean? So there's a few messages on that. And there was, in fact, bike shedding talking about whether or not the word comparable would result in bike shedding down the road. So we then, we did actually address this. So all of these things are like linked at the end of the slide. If you want to go lead it, there's like a dozen or so emails linked here. So CT log operation was something that the initial draft sort of, the authors of the initial draft of the charter had already sort of internalized how precarious the state of CT log operation is today. I think there's a perception that maybe this is working a lot better and more robustly than it actually is. And so, you know, one comment was log operator costs are actually not as much of a concern, and maybe we shouldn't focus on this at the cost of other things. However, you saw a presentation earlier today that shows that it is actually there is very, very difficult to operate a log now, and the incentive structures aren't very great, and that is only going to get apparently 97 times worse in the near future. Okay, so taking that feedback, that set of feedback, we produced a second draft of the charter. And so in this draft, we defined what we were building. We expanded the scope to include improvements to other areas, monitoring, auditing, and possibly revocation. We added the trade-off language that was suggested. The liaison relationships to other working groups is more concretely defined. This is with LAMPS. This is with TLS. This is, you know, these working groups where we have sort of this natural ergonomic touch points. And then more concretely, what the deliverables are for the working group, because that's sort of the actual point of a charter here. And so these were the three like primary deliverables in draft v2. You know, the log structure, who operates it, what is contained in the log, the certificate constructions that can sort of contain these proofs and the bindings, and the how we could bootstrap this with provisioning by us, Acme, for example, and how we could use these within the TLS handshake. Okay, so now once we had Charter v2, then there was more discussion. So feedback was included, we should be extending RFC 5280 and not X509 because we are the IETF and we extend IETF drafts. And we, there was actually a decent amount, I only put one reference here, but the disambiguation of private PKIs, various types of PKIs. Is this just the web PKI, which is this term that gets used a lot but doesn't really have a concrete uniform definition to everyone? I don't think any charter language actually says the word web anywhere, for what it's worth. There was feedback that PQ signatures aren't actually a problem, and that we're focusing on the wrong TLS metrics. And then one of the largest volume of feedback on the V2 charter was like sort of the use case here, that TLS is the focus, but should we explicitly include other use cases? Or should we just enable them to be considered and then possibly recharter if we decide that there's a mandate to include those? And then beyond just stating how PQC size is a problem, we should talk about like how that actually is going to be addressed by the solution. And so once we started getting everything in GitHub, we took a lot of these feedbacks and addressed them via pull requests. And so from V2 till now, I think these are all of the pull requests that resulted in any changes. And so these were, we should require, transparency should require more than one party to collude to subvert. That's kind of at least, it's a pretty low bar, but we should at least start there. Logs should have an externally monitorable property. Include the private or limited scope PKIs, as I mentioned. There was some going back and forth as to just whether two interoperable implementations was required by default or whether that needed to be specified. We just specified it. Cleaned up some language around amortization of costs and batching. And then we just actually straight out address how the size growth will be addressed by this solution. And okay, so this brings us to where we are today. So essentially, we went from V2, we added these pull requests, and then this is sort of the state of the charter today. But in going through all 95 something charter emails, there were a couple open questions that weren't concretely addressed with the pull request, like actually changing the text. And so I just wanted to highlight these to y'all, since this is a BOF and we may want to talk about changing some of these things or actually addressing these things. And so the questions I wanted like folks to think about, and we can maybe go back and show what the current text says, or at least the GitHub link to the current text. Have we appropriately included all of the changes that should be chartered, should result in charter changes, or basically table things for the working group? Did we properly address things like different kinds of PKIs, different protocol usage, and as someone mentioned earlier, like did we actually get to the right balance on addressing revocation mechanisms? Should they be in? Should they not be in? And then lastly, this was a late coming comment that didn't make it into I think any of the content. But should we codify Merkle tree constructions as sort of this uniform? Like should plants be the place where we codify a variety of Merkle tree constructions and have these be building blocks for other things? Should it be what plants is solving, or should this actually go somewhere else to another forum? And so I think that's sort of there was a few emails this last week on that, but it didn't seem like that conversation got to a complete conclusion. Oh, yeah, and those are the links, but you can. So I'll probably just leave it on the question slide here.
Hi, on the should additional Merkle tree constructions be added to the scope? I think this group should focus on works well for this specific application, because I think, if I recall correctly, in CFRG and other places, we've discussed, should we have general Merkle trees? Should we make these things generic? Should we try to abstract them? Blah, blah, blah. And it gets into kind of like a whole forest of trees and weeds. I think focusing on what works very specifically for this case is perfectly fine. And generally, Merkle trees show up all over the place. Making something generic for general use cases is sort of, it's kind of just doing general computation in a way. I think it's that general.
Yeah, I think I'm next. So this is in the motivational text, but I think it's having been now into working groups the past day and a half where there's been charter problems, I think it's important. This is like motivated almost entirely, and the talk is also motivated almost entirely in terms of the size performance of certificates. As a intuition pump, imagine there was a paper tomorrow that showed how to take a bunch of signatures, public signatures without the private keys, and compress them into one signature and then reconstruct it. Would we abandon this work?
I'm standing up here nodding like I have any authority. I'm
serious, because if the answer, if this is a convenient excuse to reconstruct the web PKI in a new cool way, that's one thing. If this is the only motivation is performance, it's another. And so I just think it's like not out of the question that we get halfway through this and there actually is a really, I don't know if a question algorithm, but there's an algorithm that a new PQ algorithm that has comparable size to ECC, and then we just turn this all over, turn off the lights and go home, or not. So I think it really is important to understand which one we're trying to do.
Yeah, and so I didn't want to actually get too far into the solution space here, because I think there are some of those trade-offs actually are embedded in the proposals that exist, the dispatch work. But things like changes here can affect path building and various pain points in X509 that are not just uniquely related to the PKI signature size. So there are these properties of that exist in some of the proposals that are.
No, I agree. I guess, and what I'm trying to get at here is, if this work was to be valued, I mean, if I'm trying to create a hypo it's motivational here, but if it was actually we just counted wrong and MLDSA is just as small as P256. Again, will we just stop? And if the answer is no, then the motivational text should be rewritten to say we want to actually fix problems with PKI. And if the answer is yes, then the motivational text is fine, but we should make that really clear.
Yeah, I have two separate points. Mike Ounsworth, charter enthusiast. To Ecker's point, we have a problem. Hi, Mike Ounsworth, charter enthusiast. To Ecker's point, we have a problem now. I think working on a solution to a problem we have now, and if that problem goes away halfway through designing it, we can just not publish. That's fine. Ecker wants that to be clearly in the charter. Yeah, cool, fine. Second point, Mike Ounsworth, author of the 24 new algorithms in LAMPS. Scope it very strictly so this thing doesn't proliferate, please.
Lars Wester, Cloudflare. So with a amazing small post-quantum signature, only half the problem would go away. Certificate transparency, it would still be nice to improve that. The problem is with amazing post-quantum signatures is that even if someone proposes an amazing one today, no one will trust it, right? It will take years before we get trust into it to really build the internet on. So the nice thing about Merkle trees, they are very well understood. We can use this today. We don't have to wait that long.
Alessandro Ghedini, Cloudflare. Definitely agree on keep the scope as small as possible, potentially leave some room for future expansion, but we really shouldn't, do everything all at once, which will inevitably lead to doing nothing. And similar, maybe answering Ecker questions as well. I think the scope right now should be the specific problems that we've discussed before. If we later decide, oh, actually, maybe we don't need this for those problems, but it would be nice to still have something, then it's a problem for future us rather than something to deal with it now.
Before you go, just as a clarifying question, as we were trying to judge the input on the charter, as we're talking about keeping the scope small, does that, when you look at the current charter text, which I know it's not up here and we can put up here if we want, do you think that is the right scope? Do you think it should be tighter? I understand that you're not saying it should
I
be
think it's
it.
mostly in relation to these questions. Like some of those are probably not, like trying to specify all kinds of different tree, I'd say no, because that is probably not something that is going to be useful for now. But again, maybe we can change our mind later. For the charter, like I'm not sure I've read the necessarily the latest version, but I think it was like fairly well worded and scoped.
Hi, this is DKG. I wanted to answer Ecker's question. So I don't think that all this is motivated by the size of the post-quantum signatures. So even granting Ecker's hypothetical, I do think that it is worth explicitly stating that we have other things we want to clean up here. In particular, validity windows are shrinking, which means certificates are issued more frequently. The number of endpoints is increasing, so more things are getting issued certificates, which means that the cost of running a CT log, even if PQ was not an issue, are going to be going up. They're going to be scaling up as the web scales up and as certificate windows of validity get tighter. And so let's put those in the charter as motivating factors in addition to the PQ size. It doesn't hurt to say that those are things that we'll fix, and it looks like we expect to be able to fix them.
Job Snyders. With regards to revocation, I think it's worthwhile to be explicit in the charter that logging revocation is out of scope or in scope to potentially reduce the bike shedding in the future. And from my observations, it seems that revocation is not really considered a first-class citizen. So yeah, I might add that.
Partly to Bass and partly to Ecker's observations, that would we stop doing this? I think there's another reason to keep doing this. This is kind of fundamentally different. It is kind of a certificate compression mechanism. And were it deployed, and then to Bass's point, nobody will trust it if magic happens. If magic happens and we are also in parallel deploying magic in the traditional way, and this is deployed, if the magic falls over and oh shit, we now have an alternative that is deployed, as opposed to, well, we have to wait for another magic or go back to traditional.
Hi, Stephen Farrell. I think that the current charter I just read is pretty good. I like it. I have a question. I hope it's not a bad one. It's at the end of it. It says alternate trust models, blah blah blah, are not in scope. That wasn't clear to me what that means. If that's like ruling out all sorts of things, or is just kind of a bit of loose wording, or do you happen to know what alternate trust models are not in scope means?
I'm trying to remember who actually put that text in. David, was that? Do you remember? It was in response. It was in direct response to a message.
I mean, I think the second part of it, changing how TLS uses, I think that's entirely clear and fine. I just wasn't clear what, is alternate trust models out of scope going to be used to kill really stupid, wild, bad ideas, or every other idea? That wasn't clear. I'm not asking that we fix it now.
Yeah, fair.
Go ahead, Amir.
Okay, so about revocation, it's, I actually think that revocation. Okay, sorry about that. Yeah, about revocation. Okay, I think revocation is well now in the scope and should remain in that sense. What I mean is, yes, we don't want. I think it's very good to focus, but I think we may find. Some of you know I actually have a specific proposal. We may find that the sensible solution could actually also solve the revocation problem almost for free. And that, I think, will be a great plus. So I don't ask for it to become a required part of the charter. I think the way it is now is a very good way, which is optional, and then letting me to try to convince you guys that we actually have a great solution that allows us to also solve revocation at the same time. You're not convinced? We don't do it. One small additional point about the tree, it's about the Merkle tree. I actually support focusing on for now, let's not have general standardization of the Merkle tree as the main goal. We have Merkle tree of CT. It will be very natural for implementations to extend using the same structure, and it will save a lot of overhead for the group if we focus not on trying to have a general defining of a Merkle tree. I think that's a divergent for the group. So I support also not diverging to that. Thank you.
Next, Swapnil.
Hello, this is Swapnil from speaking on behalf of Verizon. So that last comment. Can you hear now? Yeah, sorry. So last comment on the questions to consider was the one I posted that on the mailing list. So we're looking at impacts of large quantum signatures on DNSSEC. And to mitigate that, we have developed our own Merkle tree construction. We call it MTL mode, Merkle tree ladder mode. And we're looking for a home to standardize our Merkle tree construction. I know you guys have Merkle tree construction that you use for plants use case. And someone mentioned there's others that are entrenched within specifications throughout IETF. So I do think that there's value in sort of transplanting maybe a new working group that looks at documenting these different Merkle trees, their security properties, operational impacts, and standardize those such that other protocols in the future developers can point to those and not reinvent the wheel. So I think if there's community interest here, we should talk and continue the conversation on the mailing list. I'm here all of this week, and feel free to reach out or we can or on the mailing list. That'd be great. Thank you.
Hi, it's John Gray from Entrust. Yeah, just a couple of things. I've actually done some work with the VeriSign guys on the Merkle tree ladder stuff. But actually, what I was just going to ask, so in the charter, I noticed the words near the end. It says, though not the initial focus, the plants working group may consider other properties of transparent PKIs. So the word transparent, I'm assuming that's from certificate transparency, and you mean like it has to be logged? Because I'm very interested in this work, but I want to look at it, and maybe there doesn't need to be a CT log for some improvements, like revocation was mentioned earlier. I'm interested in looking at how to improve revocation itself, just the regular revocation, not logging revocation, like not putting it into a CT log, just like using revocation, using the Merkle tree to make it much more efficient, right? So is that because of that, extra word transparent PKI, does that mean that kind of work would not be in scope for this?
So based on my understanding, the use of the word transparent PKIs was an attempt to generalize back from people, it was obviously the web PKI was a motivating use case for here. And the idea is that this is sort of like to slightly pull back the specificity here to say PKIs that require properties similar to that of the web PKI, and like essentially all of the complexity contained in sort of the dispatch solutions involves sort of a transparency based sort of property of the system, like an issuance transparency. And so this was basically to not say the web PKI, because it's not about that. Like it is to explicitly open it up to use cases beyond sort of the paradigm that it was sort of being bucketed into an initial work.
Yeah, I would just suggest maybe just remove that word, because the paragraph before just talks about, being more extensible, including, 5280, extending to other working groups. So that makes sense to me. I just wondered, I guess I got a little confused by that word transparency and, all that comes with it. So maybe just removing that and be more clear that it could be in scope.
Yeah, there's definitely a jargon alignment exercise here that would be really useful, I think. So yeah.
Responding directly to John, I think the word transparent there is actually kind of important, and I would not like to remove it because I think that attempting to tackle PKI use cases that truly do not care about transparency, that just want to be able to issue certificates as fast as possible and do not care if the issuance of those certificates is auditable in a transparent, monitorable way. Even if you walled it off to your intranet, there are orgs that might want to run monitors and mirrors within their intranet, and there are orgs that don't. And I think saying, no, we are building for the case of orgs and PKIs that want transparency and monitorability will prevent us from rabbit holing on problems that are only local to orgs that don't care about that. And so I think keeping the word transparency in there is actually pretty important.
Yeah, can I just respond to that? Because I'm thinking more of like in the private PKI side of things. I know the whole motivation of this is public. I guess the word web, people don't want to use that, but private PKI side, for instance, revocation is very important. And that's where I'm coming from. So I'm just saying, if like you can scope it that way, you can keep it very, and then I'm just saying then we can't do that, right? So that's.
And to add on what Aaron said, one of the early use cases for a transparent doesn't mean publicly transparent, right? Like you could think about an auditable PKI, right? Something that has to prove to sort of an internal auditor, this is everything I've done with very high assurance. Doesn't mean that outside of that sort of network or system that is actually transparent in that, but it involves sort of the binding sort of commitment to its issuance properties.
Yeah, and similarly, I would really love for this group to tackle revocation transparency style ideas, but I do want to make sure that we tackle it in the context of a PKI that already has transparency properties, not in the context of a PKI that doesn't care about any of the other stuff that we've talked about so far today.
Cool. All right. And as a note, we've cut the queue, so let's drain out the queue. We have Boston, then Yaroslav.
As mentioned before, it's important to have transparency in mind when designing the base of this. But there's no reason why Merkle tree certificates, just cutting out some bits, wouldn't work perfectly well for a lot of private PKIs. And I see this as an excellent separate work item. If people want to pick this up in the working group, I would certainly vote to adopt that. Perhaps we could make that a bit more concrete in the charter. In one of the drafts, I intended to write something like that, but I think it didn't really come through.
A couple of things regarding the charter. First, in terms of certificate provisioning mechanisms, it seems to be very focused on ACME, which is great, but there are other provisioning mechanisms, especially in non-web PKI environments such as EST. I believe that there is nothing in the proposal that would be not compatible with EST, but still would maybe be great to highlight that we're not planning to break other certificate provisioning mechanisms. And secondly, in the second to last paragraph, it says that working group scope is to explore mechanisms for CA and transparency ecosystem. So the world's scope is to explore mechanisms seems to be awfully wide. The exploring mechanisms can take a very, very long time. So maybe worth replacing it with something more concrete.
To your first point, the ACME language, I think, was intended to be exemplary as such as, not a binding scope. It was just sort of, we can't boil the ocean for everything that exists, and the existing dispatch work already attempted to sort of find some ACME modifications to support it. So that was just an example such as, more than only that.
So Tommy has put the charter text up on the screen, and we want to just give you time to take a read if you haven't already. Hopefully you have. And then we're going to get to the BOF questions. So yeah, well, I don't want to read it. Right. But this has to do with what the goal is. Today, things are too big, and the overhead is gonna hurt. Right? That's what this part's all about. Then it talks about relying parties and how we're going to make that better for them, right? Yep. Next slide.
Yep.
Too fast? Okay.
I don't know, not too fast, but can we like get rid of the plants puns? I mean, it's no, it's not. No, it's
Look, man, you take away my spaceships, you take away my puns.
It's exactly the same thing actually. We can fight about that if you want. That's exactly my point actually. Like, can we just not be clever? Then hence no reason to have all the like forced language.
It is a Merkle tree after all. All right. Okay, so let's put the BOF questions up.
There's the end. We look. All right.
So the first question that did we open the queue back up? Okay, good. Do you think that the problem statement is well understood, solvable, and useful to solve? So if first, are there comments? And then if the queue remains empty, then we'll do a raise hands. Okay, not hearing anyone getting to the mic. So let's raise hands on question 1. It's slowing down, but it looks pretty overwhelming that only 2 people in the room think it's no. Do they want to explain why? Okay, so the consensus on question 1 is yes. So the second question, do you think the IETF is the right place to do the work? Any comments or discussion on that? Okay, then we're going to have another poll. Yes, so I think people now know how to use the tool. Okay, so one person joined the no. That,
Happy to hear it.
oh, no, there's more people going. It's still pretty overwhelming, 90 some to 5, but do any of those 5 want to say why?
No is 1, no opinion is 5.
Ah, sorry. Ambivalence is okay.
I think we slowed down.
All right. So the answer to that one is the consensus is yes. Do you think the initial scope of the charter, or do we need to discuss more about that? Don't see anyone getting in line to talk about that, so we'll do that poll question. Going up slower, but there's more no opinions. But no one is saying no. That's encouraging. So the consensus in this room is same one, my guess. Okay, we're going to say the consensus is that the initial scope of the charter as discussed is correct. Next question. Do you think the initial deliverables are correct?
We didn't have a list specifically. Yeah, let's go back.
Okay, we're going to go back to that part. That's scope. Next page.
So I think it's more. Yeah, it will define a mechanism.
Define the mechanisms that integrate log construction into certificate issuance and reduce the amount of data that an individual log entry or a TLS handshake. Integration of the log into certificate issuance enables techniques where one signature can cover multiple key and identifier bindings. That's the deliverable. Any comments? All right, then we're going to take the poll. Bless you. So more people seem to think that the deliverable list is not correct. Would anyone like to talk to the why? It's still pretty heavily supportive. Yep. There you go. Okay, the next question. Do you think a working group should be formed on this topic with the charter based on the draft charter we just discussed? Any discussion? No one's getting in the queue. So here's the question. Shall we form a working group? Yes or no? Yes, Roman.
Russ, while that's coming up, if we have time, it might be good to ask the parties. I saw at least 5 that weren't so excited by how the deliverables were framed, give them an opportunity.
When it's stabilized, I'll ask.
I guess I'll also note that for the last one, with the deliverables, we had more no's, it seems like, than the working group. So maybe that indicates we need to work on the milestones on the charter and share those. That could be. If that's not the thing, please let us know.
Say something. Yeah. Okay, so 2 people think there should not be a working group based on this. Would they like to explain why? No one's going to the microphone line. Okay. And the last question is, are you willing to help write or review documents to achieve this charter?
And I guess besides that, if you want to kind of raise hand too. This is always You will review and you will write, but you will not help.
Okay. There's got to be a plant joke in there somewhere. But all right, at least 50 people are willing to write and review, so that's pretty impressive.
We'll hold you to that.
And Deb wants your name. Okay. Thank you. Deb? Deb, would you like to address the group? I know you wanted to be off camera and everything.
You can stay down there.
You could have done it from down there.
I think that was pretty conclusive. And actually, look, I can use this one. So I think that was pretty conclusive. I said, thank you very much for the good discussion, and we will do the work to charter the working group. So honestly, though, if you're willing to review drafts, you need to submit your name to the mailing list so we know who you are. So, yeah, congratulations.
Thank you. All right, thank you all. We ended early. Please enjoy your dinners, etc., or if you're remote, whatever time you're in. Thank you for joining us. And oh, we were not prepared.